Oh, I can't. Stay gonna be quiet.
Whoa, that was not part of the agreement.
Hopefully that's pointed in the right direction.
Disrespectful.
I'm not actually sure if it is.
I think that's. I don't want to see you, so.
What if you did the entire lesson and it wasn't recording? That was so
It's recording. It's recording.
Oh my god, Miss Oswald's my favorite.
No!
It's got evidence that.
It's okay, guys. That's why you have a case on it. It's all good.
I have a case on mine and I was practicing.
Yeah, forgive me.
It's all good. Didn't break.
Why? Because I love tacos sweet. And we all know it's fake. Sweetie doesn't exist. According to
Okay, fingers crossed it doesn't fall again. Okay, so let's start with the warm up, guys. Yeah, start with the warm up. Oh, also, yeah, we get to color today, guys. So if you want your notes to be colorful, if you want your homework to be colorful, you can borrow. You guys brought yours. I have colored pencils and markers back there in the clear drawer. Be really careful not to shake the file cabinet, not my phone over, please. And thank you.
Free sharpness.
Alright, well, we are going to start with our warm-up. Alright, we spent almost 2.5 days on the last lesson. Alright, this lesson is much shorter and it's stuff you've seen before. This will not be new to you.
Oh, that's just dandy.
No.
I'm gonna have to sharpen using your sharp.
Yeah. Yeah.
how long is this lesson for?
Let's see. If you do want graphs, it is all graphing today. So if you want graphs, I have some cut out. Yeah, back there. And I have graph paper too. Or you can just use your paper, that's fine for your notes, but make sure for your your homework worksheet.
Oh wait, that's my fault.
Yeah, what kind of function is this one gonna be, guys? This is a step function, so make sure your graph looks like a step function. Alright, got the double bracket, make sure it's a step function. Think about, can you use the cheat? Can you use the shortcut? You can use the shortcut, guys.
Oh wait, yes you can.
You can use the shortcut.
It does look right.
Pretty sure. What were you grabbing? Except don't actually draw.
Oh, I wouldn't know.
Okay.
I'm just showing.
Yeah. Looks like steps. You got it? That's good. I would offer if someone wants to come up to the board, but we all know how finicky my board is. Oh, I'm
I
very
used to do that
bad.
all the time in
Never even
middle
for
school. I loved going up the boards. Yeah.
So fun.
I loved going up there. But now I
You
won't.
can, well, if you want to, you can.
I'm good.
What?
I summoned
You just
Sears
said I
Spears
totally
to
go
the
up and
table.
go to the board.
I'll try it.
Okay.
If it like doesn't work, then I have to.
Alright.
I said
Bad,
Sears
but I'm
Spears, not
bad
only
at
one.
writing
This is absurd.
You know, I've had this board now.
Huh? No. It was off by like a hole.
I've had this board now for what? This is my 5th year, so this is my 5th year with it. I know it's you know, it's kinks, so I'm kind of.
That was kind of funny.
You might want to sit
Yeah,
down.
it's, literally, that was a funny scoff he did. Giggles.
So my question to you guys. I already asked, can we use the shortcut?
No.
Yeah.
Yes, right? Remember, you can't always use the shortcut, however, I can for this one. Why? Why can I use the shortcut? Because the 2 is outside the greatest integer function, right? If that 2 was inside those double brackets, I could not use the shortcut, but it's not, so I can. So what am I actually going to graph then for my shortcut? What am I actually graphing, guys? Why am I starting at 1?
Because
Y
there's one
equals
in front of the
2x plus
integer.
1, right? So I'm
That's
actually
fine.
going to graph y equals 2x plus 1, right? I'm going to make it a linear function. Now, I always harp on you that you can start at the y-intercept and move your slope. But, do I have to start at the y-intercept? No. When it's in slope-intercept form, and you can actually start at the y-intercept because it's on the graph, then for sure, right? What are the 2 things you need to graph a line? A point and a slope, or do you have to have a slope? No, so either a point and a slope, or what's your other option? How many?
Oh,
2. So either 2 points, or you need a point and a slope, right? Okay, so this though is nice, right? I have a nice y-intercept that's on my graph, so I can start there, right? That's just one of those special points. It's still just a point on the graph. So where am I going to start then?
1.
At 1 on 2 on the y-axis, right? Right? Don't start it on the x-axis, it's the y-axis. Okay, from there, how do I move? Up 2 over 1, right? My slope is 2, so up 2 over 1. What I got? Or going this way, right? Now, if it was a linear function, what would I do? I draw the line, but it's not. What is it? Step function. So instead of drawing the line, I'm just going to, oh, that is off. I didn't think that was right. All right, instead I'm going to make my little steps, right? Go over, open circle.
I can't imagine drawing a step function on this board.
Yeah.
That's gonna be awful.
Okay,
Drawing
hopefully
one
yours looks a little more neat than mine since you can actually control where your pencil is.
Yeah.
Okay, any questions with this? Do we feel more comfortable with step functions now that we've kind of spent a couple days on them? Right, this was brand new to us. Yes, Logan?
So the shortcut is if the number's outside of the bracket things,
As
that's
lo-
when you do the cheat.
As long as there's not a number right here, you can do the shortcut, yeah. As long as that's 1, you can do the shortcut. Doesn't matter what's outside of it. Okay, so any questions on those?
If it's like x plus 1 and it's on the bracket, would that?
Still fine. It just can't be the number in front of it, because that's either gonna make the steps shorter or it's gonna make the steps longer.
Oh, so
That's what that changes.
if the x is being multiplied with anything inside the brackets, it's not okay. If it's being added or subtracted,
It's
it's
fine.
fine?
Yep,
Okay.
it just can't be multiplied, because then that's gonna make our steps shorter or larger. In which case, then we would have to do the intervals. Okay, some of you already turned your homework in. If you haven't yet, I want 3 piles. I think, yeah, you turned it in. All right, piecewise step function and bookwork. I need 3 piles. Half of you, I think, turned it in, so I have it in my pile. I was gonna start grading it, and I didn't get to it yet. Stapler, right here. Yep. Yeah. Make sure your name's on it, guys. I still have like 4 papers in my no name bin. Some of them are Algebra 2 stuff, so I don't know if they work.
Are you in the worksheet? I'll take it.
I don't think so.
Sorry, El Camry.
I will have all of your grades updated with everything that's been turned in absent or late Actually, it should already be in, I think there's only, I only have one that I haven't graded this week, so. If you think you turned something in, and it's a 0 in the grade book, you might wanna check the no name in.
No, that's not mine.
Cups, we bought cups this weekend, and I got bring them again.
What is this stuff?
Also, if anyone wants, I have something
Candy?
somewhere.
Wait, you forgot the joke.
Oh, I
What?
did forget the jokes, oh my gosh. I'm so
Yeah.
focused on everything else, I totally spaced on the jokes.
That looks some
You wanna look
No.
some up? They better be appropriate.
They're gonna be so bad.
Internet jokes are big.
Unless you.
Here we go, I knew they were in this file. If anyone wants any extra practice on piecewise functions, I have a worksheet if anyone wants extra practice on it. Also though, we were gonna have the test next week on Halloween, right? That was the plan. However, I have decided for us to do a project instead. We're still gonna do the test, it's just gonna be the next week.
Oh, thank goodness.
Okay, so we're gonna do a project and it's gonna take both days. Okay, both Tuesday and Thursday next week, we're gonna work on this project.
Oh, yeah.
Tuesday, you guys are gonna start by drawing your picture,
Oh, drawing.
and then we're gonna work with Desmos. Yes,
Alright, I have jokes.
jokes, here we go. Everyone listening?
Why is 2 plus 2 equals 5 like your left foot?
Change the joke, I don't like
It's
it.
not
It's
right.
not right. Yeah.
Did we do why was the tomato red? Did we do that joke? We haven't done why was the tomato red?
Because it was embarrassed.
Because he saw the salad dressing.
Oh, that's way better than your jokes.
What do you do if a teacher rolls her eyes at you? Pick them up and roll them back to her.
That's great.
Comedy.
It's also rolls her eyes.
Yeah, which I do all the time.
Oh, yeah.
What's a math teacher's favorite dessert?
Oh, pie?
Yeah.
But yes, nice. All right. So anyway, like I said, today we get to color. You guys get to be like your
Sixth graders.
your inner child gets to come out today.
No,
Okay?
don't let it come out. I don't like coloring.
Okay, this is our last lesson of chapter 2. This is our last lesson of chapter 2. Like I said, next week when I see you on Tuesday, we're gonna start our project and we're gonna finish it on Thursday, unless you don't finish it, in which case then it becomes homework. The following week, Monday then, we're gonna review and do like story problems, and then Wednesday's gonna be our test. That means though, guys, we're not having another test on quarter 1 grade. So, if you're not happy with your quarter 1 grade, the only thing you can still do at this point in time is retake that quiz. And turn in all your homework and get 100% hopefully on your homework, and if not, redo your homeworks. Right? That's about it, because November 5th is the last day of quarter 1, and I'm pretty sure your test now falls on the 6th, if I remember correctly. Someone want to help me with that?
So excited.
I'll look at my calendar. Okay. Yeah, because I'll see you the 6th. So yeah, that test will be the first thing that goes in for quarter 2 though. So, if you want to start out the quarter well, we want to do well on the test. So hopefully this project we do really helps you with piecewise functions. That's what most of it's going to be. So, anyway, like I said, we're going to do the last lesson of chapter 2 today, so we're graphing inequalities, right? This is where we get to have fun and we get to color, you get to be colorful.
I like colors.
And use your pencil.
You can, that's fine, you can just use your pencil.
Okay.
It doesn't have to be colorful, I'm just saying you can use color if you want. Okay, so, I have an example up here, right? This was what it's gonna look like for graphing an inequality. We did this in Algebra 1, hopefully we kind of remember it. Alright, so if I have the inequality y is less than or equal to 3x plus 4, right, you're gonna draw the line y equals 3x plus 4, and then, do you remember, is the line always solid?
No.
No, what else can it be? Yeah, dotted or dashed, yeah. Do you remember when it's which one causes it to be that?
Greater than or
Isn't it-
equal to versus just greater or less than.
Yeah, so like if it's or equal to, right, then it's your solid line. If it's strictly greater than or strictly less than, it's gonna be dashed. Right, just like when we were graphing on the number line for inequalities, right, open circle, closed circle, kind of the same thing, solid line, dashed line. Okay, so anyway, the line we draw though is called the boundary of the region, right, and we're either gonna shade above it or we're gonna shade below it. Okay? So, does everyone have this? Are we still going? If you're putting this in your notes, like I said, it's your notes. Okay, notice my line has what on the ends of them? Because it's the
Arrows.
lines, arrows. I'm gonna tell you right now, I will take off points if you draw line segments. These are lines, make sure you put arrows on them. These cups don't keep this coffee hot, you know? Okay, so like I said, we get the shade above or below, so if you wanna use color, feel free. If you wanna just shade with your pencil, that's fine too. I don't care, as long as you shade the right side, or the right half, right? Okay, if you haven't written that down, make sure you write that down. Solid line if it's greater than or equal to, less than or equal to, and then dashed line if it's less than or equal to, right? If it doesn't have the or equal to, it's dashed. Yes,
Wait, what does the dash line look like?
so,
Oh.
just like that, yeah. Alright, so, do you remember, did we talk about it this year? Did we talk about what it means to be a solution of an equation? Did we talk about that this year? I know we did a couple years ago, but did we talk about it this year? Do you guys remember what does it mean to be a solution to an equation? Like, if I gave you this, what's the solution to that? 7, right? 7 is my solution.
It's whatever makes the statement true.
Thank you. Oh my gosh, yes! It's whatever value or values makes the equation or the inequality true, right? It's what number can you plug in that makes it true. Now, is it always 1? Is there only one answer? For this one, yes. But if I have an inequality like this, how many solutions would make that inequality true? Anything where?
Oh.
Less than or equal to 3x plus 4.
Right? Pretty much anywhere in here, actually anywhere in here, doesn't matter, any of these points, including points on the line, right? Because it's a solid line, so it means or equal to, so it can be the line, right? Any point in there is a solution to this inequality. So how many solutions does this have? Infinite, right? There are infinite solutions, okay? So when we go to start shading these, I'm going to teach you a couple different ways to do it, and you can choose which makes more sense for you, right? But the point is that this has infinite solutions. Every single point you can think of, whole numbers, fractions, decimals, everything inside the shaded region is a solution, and everything on that line is a solution. But when you have a dashed line, okay, your only solutions then are in the shaded region, right? The points on the line are not solutions because it's not or equal to. Does that make sense? Yeah? Okay. Alright, so let's go to some examples here then. You might want to write down what we just talked about a solution is. Hint, hint, nudge, nudge, wink, wink. The value that makes it true. The value that makes it true. Equation or inequality depending on what you're doing. Okay, so, right, I have a graph. Now, there's multiple different ways ways to graph this, right? Yes. We could graph it by intercepts, we could change it into y equals mx plus b, right? We could just pick two random points. However, when we deal with inequalities and shading, you're probably gonna wanna solve it for y. Because right now it's saying that it's greater than -3, right? So if we do method 1, where you figure out which way to shade based on the sign, you're gonna wanna solve it for y. Otherwise, if your sign flips, what causes a sign to flip in an inequality?
If you multiply or divide by a negative.
If you multiply or divide by a negative, right? So if I were you, I would just solve it for y. You don't have to, you can graph it by intercepts if you want, picking 2 points, but I would solve it for y. So if we were to solve this one for y, what would we do? Add x, right? I want to get y by itself, add x. Is that greater than -3x? Does that become -3x?
No.
No, those are not like terms, so I write it as,
X minus.
oh god. There it goes again. Okay, right, I'm gonna write it as x minus 3, right? Or you can write it as -3 plus x if you want. Just remember, the number in front of x is your what? Slope, right? The constant added or subtracted at the end is your y-intercept, right? It is the special point we can start with if we're going to graph this. So if I was to graph this just based on that, where would I start? At -3 on the y-axis. I know I keep harping on that, but I always see people starting it on the x-axis. This is the y-intercept. Make sure you start it on the y-axis. Okay, from there, how do I move? Up 1 over 1, right? Yeah, it's, okay, then you have to determine, is it a solid or a dashed line? It's a dashed line, right, because it's strictly greater than. Also, you guys should be using what to graph these? Rulers and or a straight edge, please. Especially when we get into solving systems of equations, because if you draw your lines and do it all willy-nilly and hope that you did it right, you might get a wrong answer because it doesn't actually cross where it's supposed to. Okay, now the question is where do I shade?
On
Above.
the right.
Above it, right? It's
Right.
greater than, so I'm going to shade above the line.
Bless you.
Bless you. Okay, now, if you want to check that, or you're just not sure if you shaded the right side, right? Pick a number, right? Pick a point. So, if you can, pick the easiest point there is. What's the easiest point that you can use to plug in? 0, 0. So, as long as your line does not fall on 0, 0, that's the point I'd pick, okay? So, here's 0, 0, right? Plug that into your inequality here. Okay? Is 0 greater than -3?
Yes.
Yes. So if that's true, then that's the side that should be shaded, right? Whatever side 0, 0 falls on the line, that's the side that should be shaded, okay? Do you have to do this? No, you don't have to do this. This is if you want to check it or you're just not sure, because sometimes these lines are going to be pretty steep and it's like, okay, well, which one's actually above it, which one's actually below it? Okay, if you ever want to check, go ahead and pick a point. If you can pick 0, 0, it's the easiest point, right? Okay, any questions with this one? Okay, ready for the next one? Okay, once again, You don't have to solve it for y, there's no negative, so really we don't have to solve it for y. But, I don't know. It seems easier just to solve it for y equals mx plus b. So what would I do if I wanted to get y by itself?
Subtract x.
I could subtract x. Okay, where would I start?
2.
At 2. What's my slope?
Negative 1.
Negative 1, so down 1, right 1, right? Or up 1, back 1? Solid or dashed?
Back.
Dashed. Oh gosh. Hmm. Okay, you guys know where that's supposed to be. Okay. Not gonna bother calibrating. Last time I calibrated, it just went even worse. Okay, so which one am I gonna shade? Above, right? So which one's above this time? The right side. Right, last time though, above was actually the left side. What's different about it?
That was positive, negative.
The slope, right? Once again, you can always check it, pick a number, right? Pick 0, 0 again, it's not on the line, so go ahead and pick it. If I plug in 0, is 0 greater than 2? Is 0 greater than, no. So that means that wherever the 0, 0 is, that should be the side that's not shaded then, because that's not true. Is that how we have it shaded?
Yes.
Yes, right, 0, 0 is not shaded, which it shouldn't be. It doesn't make the inequality true. It's not a solution. It's not a long lesson today. So I said the goal.
Wait, how many more?
Two more.
2 more slides?
Yep, 2 more slides, 2 more graphs. The goal is, you know, it's a long weekend this weekend. I don't want you to have homework, so hopefully you can get it done in class. That's the goal.
Thank you for your kindness.
You're welcome.
Get that camera.
Is that 2 slides excluding this one?
Yeah.
Okay.
Um,
On one graph.
just out of curiosity, right, if I was, remember if I was to graph this by intercepts, do you remember what we do?
No.
Remember, if you wanna find the y-intercept, we plug in
X. No.
0 for x. We just did
Yeah.
this, yeah, right, remember we covered it up?
I remember.
What would your y-intercept be? Just 2. Don't pretend it's not a greater than.
Oh.
What's your x-intercept?
2.
2. I know my graph doesn't work out, but did that actually happen? Yes, can we graph it by intercepts? Yes.
Oh, cool.
Right, the only time you might wanna be careful with that is if we have negative numbers we're gonna be dividing by. That's where you wanna be careful. So, this one, what am I gonna do?
So we have 2x.
Subtract 2x if I'm gonna solve it for y. Oh.
Oh, wow.
Oh, that's beautiful.
Oh dear. You might have to recalibrate.
I might have to try that again.
Modern art.
I know. You guys knew I was an artist, right?
Oh, yeah. Oh, see now, oh, I forget saying anything.
Do you know what it is? You guys know what it is. You
Yeah.
know what it's supposed to be. You're doing it on your own paper. Okay, then what?
Divide by 3.
Divide by 3. 2. Oh god, everything.
Something that looks worse than my handwriting? What?
Does 3 go into 2? No, so I have to leave it as a fraction. And negative 3 divided by 3 gives me negative 1. Alright, so if I'm going to put it in slope intercept form now, where am I going to start? Negative 1. How am I going to move?
Down
Up
one,
2,
down
down over 3, and going to the left.
Yeah, so I can either go up 2 and then back 3, or I can go down 2 and right 3. Alright, rise over run. Okay, solid or dash line? Solid, because it's or equal to. That's pretty close. Oh, good enough. It's hard with this board. Okay, so just out of curiosity, right? If I cover up my x, I plugged in 0 for x, what's my y-intercept?
Negative 1.
Negative 1. Okay, look at that. If I cover up my y, because I'm plugging in 0 for y, what does my x become? Close, sweet. Negative 2, 3. Negative. So for x, guys, what would you do?
Negative 3 over 2.
Negative 3 over 2, right? You gotta divide by 2. You know, it's kinda hard not writing it down. So what's negative 3 over 2?
1.5.
Negative 1.5. Is that where it hits?
Yep.
Yep.
So,
Anyway, which way am I gonna shade?
To bottom.
Bottom. I want
Nice.
below. I want
Really
below. It's less than. Once again though, right, pick a point, plug it in, check to make sure it works if I plug in 0, 0. Is 0 less than or equal to negative 1? No. Which means the side that has 0, 0 should not be shaded. Is that the case?
Yes.
Yes. Any questions so far? Pretty easy, right? Graph your line, figure out if it's solid or dash, figure out which way to shade. Okay.
I think we're ready for the homework.
Oh no, I got one more for you.
I feel like it's gonna be really tricky.
It's gonna be so tricky.
White was.
Oh my goodness!
I don't know how you expect us to do this.
I know, gosh, I'm such a mean teacher.